Welcome back everyone. In this video we're going to be talking about data contextualization in manufacturing and more specifically within the context of industrial automation. And we're going to be talking about why it is important, especially as you reach levels such as SCADA, MES, and ERP. We're going to be referring a little bit back to the previous video I did on the different ISA automation layers. So if you haven't seen that before, that's going to be in your corner right now. But ultimately, we're going to be talking about how to get context from data, what it truly means to have context for specific signals. And I'm going to be breaking this information down for you to make better decisions and to have better conversations, whether that's with internal teams or whether you're bringing in somebody externally that's going to be working within the context of those layers and ultimately working on the data to be sent from the plant floor into SCADA, MES, or ERP. So without any further delay, let's dive right into this immediately. So what is context for manufacturing data? Well, at the fundamental level, when you have a PLC system, and here I can pick up the same pair of PLCs, the Automation Direct as well as the Allen Bradley, the PLCs do not know what kind of device is connected to them until a programmer gives them that context. So ultimately, what does that mean? Well, on the plant floor, you can have different sensors. You can have digital sensors, you can have analog sensors, you can have devices that talk over different protocols like Ethernet, RS-232, RS-485, but ultimately for the PLC, it does not truly matter what the device is. All it cares about is the signals and the values it's receiving from that device, and it is sending to some of those outputs. So ultimately, if I connect something to input 1, it could be a temperature sensor, it could be a pressure sensor, it could be a flow meter. The PLC does not necessarily know what the device is. So what it takes is, it takes an engineer that's going to program that PLC, and as I've mentioned in the previous video, the primary function of the PLC is to execute control loops. So ultimately, a very basic example would be if the temperature drops below a certain level, which is called a set point, we want to turn on a heating system. So the PLC is going to continuously read that sensor, which is going to be reporting the temperature. The engineer is going to say, well, once the temperature dips below the specific threshold, we're going to send a signal to an output, which again, the PLC does not know what's at the end of that output. All it knows is that the PLC has energized the output and something has turned on. But ultimately, the engineer has tied, or the electrician has tied, a heater at the end of that output, which should result in the temperature to go back up above the threshold. So when you're starting to talk about systems like SCADA, MES, or ERP, it is extremely important to know what kind of data and what kind of sensor information you're capturing, and without knowing what that information means, it is impossible to make any decisions, right? And so remember that in a very simple control loop like I've described, you don't necessarily need to know what happens with that temperature over time, what happened with that temperature last week or last shift, but ultimately at the MES and ERP layers, that's what you truly care about. So simply extracting the value from that sensor, which resides on the raw form on the PLC, is not sufficient. Somebody needs to go into that system and say, this is the temperature of that specific tank, which ultimately relates to the batch, which then can be monitored over time. So if I can draw a simple diagram, so again, your data in raw form is going to come from your field devices. So field devices. And this is going to be true across different protocols, right? So it doesn't necessarily matter how it is connected to your PLC, which is going to be this next layer, but ultimately for control purposes, you're going to be sending that data to the PLC, and then you're going to be actuating certain outputs based on the state of your system. And I've described this in a lot more detail in the previous video, but ultimately this is where raw data is going to reside. Now, raw data just means that the PLC is extremely fast, so it's going to be picking up those signals every scan cycle. Again, there's a lot of discussion to be had as to when the PLC picks up and updates inputs and outputs, but ultimately imagine that this data every 4 milliseconds or so, depending on the system, it could be lower than that, it could be a little bit longer than that, but ultimately every 4 milliseconds, the PLC is going to update all the raw registers within itself. Then the PLC is going to be pulled, or essentially be asked for that data to be sent to the next layer. So like I said, it doesn't necessarily mean that the data needs to go through SCADA in order to reach MES or ERP. It can be going directly all the way to the ERP side. It could be also going directly to the MES side, but ultimately what these systems are going to need is not just the raw data, they're going to need raw plus context. So I'm going to add here raw plus context. And so there's a few ways of getting this done. So ultimately you can add context at the PLC level, but I would argue that PLCs are not necessarily good at storing strings of information. So if you wanted to add, for example, information on the context, where does the data come from, right? So we talked about the temperature measurement of a specific tank. So probably you want to say this is facility XYZ, line number 5, production machine or tank, let's say 6, and that's the temperature we're sending, right? So you have the raw value, which is, for example, 70 degrees Fahrenheit, plus you have the context, which is going to be, I don't know, site 6, line 4, tank 2, right? So this is going to be your context. As I said, it can be added in multiple ways. It can be added at the MES layer, it can be added at the ERP layer, it can also be added what's called on the edge. So like I said, PLCs are not really good at manipulating strings, therefore it's very rare that you would spend the time necessary to go in and tag every single value that you need to pass along at the PLC level. So normally what you would see is an edge device, right? So an edge device is nothing more than a computer or an IPC, industrial personal computer, which ultimately means that it can add that context before funneling that information upwards. So the edge device typically would reside here inside of the control cabinet, and all it's doing is just pulling the data from the PLC. It is obviously discarding the data that is not needed by the upstream systems, and it's adding that context to the specific measurement. So then when it comes to the MES and ERP systems, not only can multiple vendors or multiple different solutions pull from that device, they can also immediately have context with the value, which is, like I said, not something you'd commonly see at the control system level. So hopefully that explains context for your data. Like I said, there's really not much more to it. The challenge in manufacturing, right? So I want to discuss as to why this is important, right? So as we're getting more and more data for decision makers, for data scientists, for people who are looking to manipulate or understand some of these systems using AI, if they don't have the context, if they don't understand where this data is coming from, what it truly represents, all they have are numbers. And it is very difficult, if not nearly impossible, to draw any conclusions besides simple deviations, right? So, for example, if you have 70 degrees as the set point and, for whatever reason this value dips all the way down or all the way up, you could say that the value is out of what it should be. But ultimately, it's very difficult to draw a conclusion on value that you don't understand what it truly means. And if by saying that this is a temperature, right? So this is site 6, line 4, tank 2 temperature, you are giving the necessary information for the data scientist or for AI to understand, well, typical temperatures of this tank should be within 70 degrees Fahrenheit, and they probably range from 50 degrees all the way to, let's say, 100 degrees when it's being heated. And so this is the range that we would expect. You can then apply a machine learning model to understand if it's within range. The last point I do want to make is, why is this so complicated? Why has this not been solved, or why is this an unsolved issue in the current state of manufacturing or industrial automation systems? And the reason for that is, like I've mentioned a couple of times, PLCs are not necessarily devices that are optimized for manipulating data. And so when you program a PLC, you need to give it context, and you will be doing that for different systems in slightly different ways depending on the vendor, depending on the device, but you're optimizing for running a process. You're not optimizing for understanding the intricacies or the details of that process. Now that we're in the stage where we need to learn more data and understand more about the process, someone with that knowledge needs to sit down, understand what kind of signals we're looking to pull into the higher level layers, and to give them context so that the data that is synthesized from the raw information can be then used to make those decisions.